In this video, we'll be discussing function operations, and then our objective is to add, subtract, multiply, and divide function operations and find the composition of those functions. First, you can do the four major operations with functions. So you can add functions together, you can subtract functions, you can multiply functions, and you can divide functions. Now, in the case of dividing functions, you need to be careful. Whatever the denominator is, that function, you just have to make sure that it does not equal 0. So for in this case, g of x cannot equal 0 because you cannot divide by a 0. Now, so let's actually do some practice. So if we have two functions of f and g, let's perform each of these functions. So what I want you to do is actually pause the video, and I want you to try to attempt these and then resume the video to see the answers. So for the adding and subtracting, in this case, I want to know when x is 2, what will these functions be? So there's two ways you can do this. You can either add f of g first and then plug in 2, or you can plug in 2 first and then add f and g. So I'm going to go ahead and do the first one first. So I'm going to first add these two together. So 3x minus 2 along with x squared plus x. I'm going to combine like terms. I have an x squared, I have 3x and an x, so I have 4 x's, and then I have a minus 2. So now I'm actually going to plug in 2. So now plug in 2. So if I do that, I will get 2 squared plus 4 times 2 minus 2. So I'll get 4 plus 8, which is 12, minus 2 is 10. Now the other way to do this is plug 2 into each of these first. So if I plug 2 into the f, and then I plug 2 into the g, will I still get 10? So, well, 3 times 2 is 6. 6 minus 2 is 4. 2 squared is 4. 4 plus 2 is 6. So if I was to add f and g together, 4 plus 6 did give me 10, so it worked. It doesn't matter what you do first. So that is when you're actually wanting to plug a number in. Now, in this case, they do not want you to plug in a number to find an actual answer. They want to keep the variable. And be careful, they want the g to go first. So you have to make sure that the g is put first, and then you're going to subtract the f. So when you do that, you need to distribute this minus. So I'll get x squared plus x minus 3x, and then a plus 2. Again, you need to be careful. This minus and this minus turn into a plus. So you have x squared, 1x minus 3x will give you a negative 2x, and then you have a plus 2, and that is going to be your final answer for that function operation. Now in this case, you are multiplying, and so you're going to take f and you're going to multiply it by g. So you're going to have to FOIL this. So 3x times x is 3x cubed, 3x times x, sorry, that was 3x times x squared. 3x times x is 3x squared. Negative 2 times x is a negative 2x squared, and the negative 2 times x is a negative 2x. Combine like terms, you only have 1x cubed, so it stays in the front. 3x squared minus 2x squared gives you 1x squared, and then minus 2x, and that would be your answer if you were to multiply those two functions together. In the case of division, again, they're wanting you to plug in a number 3, so you could do one of two things. You can either divide them first, or you can plug in 3 first. It does not matter. So they want the g to be first, so it would be x squared plus x, and on bottom it would be 3x minus 2. Now I'm going to plug in 3. So I have 3 squared plus 3 divided by 3 times 3 minus 2. 3 squared is 9, 9 plus 3 is 12, 3 times 3 is 9, and 9 minus 2 is 7, and so our answer would be 12 over 7. Now there's also something called the composition of functions. Now the composition of function is where you are going to take a function and you're going to take that entire function and plug it into the variable of your next function. Now, the domain of this is going to be the set of the domain of the domain of g such that g is inside the domain of f. So, again, the composition of functions mean that you will first evaluate x in the most inner parentheses, or in this case, the variable the function that is closest to x, and then you'll take the result of that, and that is what you're going to plug into f. So be careful, be careful. Order matters in this case. So another way to look at this is basically you are inputting something into a machine, into G. Whatever is taking out of that, the output of that is actually going to become the input into the next function. So for example, if you had a pizza for a function and if you had a pineapple for a function, if the pineapple went first, you would put the pineapple in the pizza, okay, because the innermost goes first. However, if the pizza was first, then you would put the pizza in the pineapple. So let's actually do a problem, but first let's actually talk about if it was a graph. So they want you to evaluate g of f of -7, and this would be written as the same thing as g of f of -7. So either one of these can be written. They're interchangeable of how they look. So here's what you do. You're first going to do the innermost function. I want to know what is f of -7. So over here in the f, I'm going to go to -7, and I'm going to find where that is on the graph. This is the coordinate point -7, -3. Because -7 is your x, -3 is your y. So if I was to plug in -7, then -3 would be the output. That means you're going to plug the -3 into G. So now you will say, what is G of -3? So now you go to the -3, and then you go down to where it crosses or is at the function, and you find out your y value. This is the coordinate point, -3, -6. So if you plug in -3, then your output becomes -6. So again, you take the number, you plug it into the first function that is closest to that number. So I figure out what is the y value at -7. It is -3. That answer, the -3, is what gets put into the next function. So let's do one more. G of f of 2. Again, we're going to plug the 2 into f first. So we're going to find 2, and we're going to figure out where that is on the graph. This is the coordinate point 2, 1. So if I plug in 2, I will get an answer of 1. So we know that we get an answer of 1. This answer is what gets plugged in to G. So now I want to know what is G of 1. So you go to 1, and then you find out where it is on the graph, and this is the coordinate point 1, 5. So the output becomes 5. Again, you take the number, plug it into the first function. The answer that you get from that function, that is what becomes your new x. So now let's do it algebraically. Let's go back to what we had at the very beginning of the functions, and I want to do f of g of 2. So what it says is I am first going to plug 2 into g. So I am going to find out what is g of 2. 2 squared plus 2 is 6. So I know that g of 2 is the number 6. This is what gets plugged into f. So now, what is f of 6? Again, you're not doing f of 2, you're actually doing f of your output. You inputted the number 2 and you got 6. That is what gets put into f. So now plug in 6 into your f, and 3 times 6 is 18, and 18 minus 2 is 16. So that is your answer. F of g of 2 is the number 16. Now let's actually do it backwards. We now are going to plug 2 into f first. So plug 2 into f. So f of 2 is going to give me 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 is 4. This answer, the 4, that is actually what gets plugged into g. So now you want to know g of 4. You don't want to know g of 2. You actually want to know g of 4. So now you're going to take a 4 and you're going to plug it in to g. 4 squared is 16, and 16 plus 4 is 20. So if you notice, you're plugging 2 into the first function, f of g, g of f. However, you do not get the same answers. If you plug 2 into g first, then plug it into f, you get 16. If you plug 2 into f first, then plug into g, you actually get 20. So order matters. You got to be careful which order. Now in this case, you're not plugging in a number, you're actually keeping the x. So first plug x into g. Well, we already did. It's already in terms of x. So what you have to do, this is where it gets a little weird, if it hasn't gotten weird already, you're now going to take that entire function, like the entire function of g, and you are going to plug the entire function into the variable of f. So the function of f is 3x minus 2. But instead of x, you are substituting the entire function of g. So your answer is going to be 3x squared plus 3x, because you got to distribute the 3, and then a minus 2. Do not distribute the 3 times 2. The 3 is only with the parentheses. So in this case, we are doing f of f. So what you're going to do is we're going to take the function of f, which is the entire function, which is 3x minus 2. And now we're actually going to plug 3x minus 2 back into the variable. So we have 3x minus 2, but instead of x, we're going to plug the entire function in to the x. So our final answer is going to be 9x minus 6 and then a minus 2. So we get 9x minus 8.